Welcome to the deep dive. Ready to tackle a big one today.
Always up for a challenge. What have we got?
Well, we're asking, what if time is just energy in motion? We've got this excerpt, and it's really making us rethink some basic stuff.
Yeah, it's a pretty radical idea. Instead of thinking of time as like its own separate thing.
Right, like the fourth dimension, all that.
This excerpt says, what if it's all about how we experience energy constantly changing?
Okay, so usually we picture time as a line, past, present, future. But this is saying we don't actually see time, just things moving.
Right, think about it. Earth spinning, that gives us days. It orbits the sun, we get years. Our solar system's moving through the galaxy, the whole universe is expanding.
So those are all just measuring movement, but not that time itself exists.
Exactly. None of those prove time exists on its own.
So, I mean, we see a clock ticking, but we're seeing the mechanism, not time itself, right?
Right.
I'm trying to get this straight. If everything in the universe just stopped moving, would time stop too?
That's the huge question this excerpt asks. If time is how we measure motion, then yeah, without motion, time doesn't really make sense.
Whoa. Okay, the excerpt also says time isn't a force. Not like gravity, you can't contain it.
Exactly. It's not something you can like point at or bottle up.
So it's not a thing you can manipulate.
More like it comes from things, from the energy and the motion.
So less like a ruler, more like, I don't know, ripples. Something's got to cause it to happen. But wait, if that's true, then why do we age? If time isn't pushing us to get older, what's going on?
Well, this excerpt says aging isn't because of time itself, it's because our bodies break down.
Like they wear out.
It's about energy loss, entropy. Our bodies use energy and they wear down over time.
So it's not the years, it's the mileage.
Exactly. Yeah. It's a really different way of thinking about it. Imagine this. A human body, it uses a lot of energy, right? Might last 80 years. But a rock, it barely uses any. It can last for billions of years.
So if it was just time making things old, shouldn't they decay at the same rate?
That's a good point. The source uses that same example, and it says, aging is more about how well our bodies use energy, not just time passing by.
Okay, but then what about entropy? Doesn't that mean time moves forward? We always hear entropy increases over time.
That's a common one. This excerpt actually says entropy isn't about time moving forward. It's about energy spreading out, wanting to be balanced.
Not things falling apart, but energy evening out.
Exactly. Like imagine a hot cup of coffee, it cools down. Or a star burning up all its fuel.
Classic entropy.
Right, but it's not time doing it. It's just energy naturally wanting to be spread out evenly.
Okay, so instead of the universe ticking forward in time, it's more like it's always rearranging energy.
Yeah, like a giant cosmic, game of Tetris where those blocks are always falling into new spots.
That's a great analogy. So entropy isn't some force making the universe messy. It's just energy finding its balance.
That's a good way to put it.
All right, so we've messed with clocks, messed with aging, messed with entropy. Now let's get really weird. Black holes. Places where time supposedly stops.
Yeah, black holes definitely make us question how we think about time. Physicists say the closer you get, the slower time seems to go, compared to someone far away.
Hold on. Time slows down. So if you were falling into a black hole, would you feel it slowing down or would it seem normal to you?
That's the tricky part. It's what makes them so fascinating. But our source says, maybe it's not time itself slowing down, it's gravity warping how energy works in that crazy environment.
Okay, I'm going to need an analogy for this one. It's getting a bit much for me.
Okay, imagine a whirlpool. From far away, it looks like the water's slowing down as it gets closer to the center. But if you were in a boat caught in that current, you wouldn't feel time slowing down. You'd just be spinning faster and faster.
So in a black hole, it's not time stopping, it's just energy getting trapped.
Exactly. It's trapped by that super strong gravity. Looks like time slowing down to someone watching from outside, but if you were falling in, it'd feel normal.
Wild. So again, it's not that time is this separate thing. It's all about how energy's acting. All right, we've covered a lot. Clocks, black holes. I'm feeling like my brain's doing bicep curls here.
Good workout.
But we're not done yet. Next up, we're diving into Einstein's theory of special relativity and what happens at the speed of light. Stay with us.
Back again for more deep dive. Before we, not a break, since time might not even be real, we were right in the middle of black holes and how they mess with time.
Yeah, still a bit dizzy from that one. But okay, so black holes, they warp time because of that extreme gravity. But now let's add in Einstein and his theory of special relativity. That one says the faster something moves, the slower time goes for it, compared to, like, someone standing still.
Which brings us to the ultimate speed limit, light speed. According to Einstein, at that speed, time theoretically just stops. Full stop.
Wait, so time stops. But light still travels, right? From a star to our eyes. How does that even work if time isn't ticking for the light itself?
Yeah, it's definitely one of those things that makes you go, huh. But our source, it offers up this idea. It's not that time literally stops for light, but that energy at that speed, it just acts completely different.
So it's not like light's experiencing zero time as it's zipping across the universe. It's just outside our normal time rules.
That's the idea. Light, it's pure energy in motion, right? It exists in a way that our brains, evolved for this much slower world, can't quite grasp.
Okay, yeah, I think I'm getting a headache just trying to picture that. But this journey through time, or maybe the lack of it, isn't done yet. We've got relativity, we've got black holes. Now let's get really weird. Quantum mechanics, where the normal laws of physics basically say, see you later.
Right, and our source makes this point. At that quantum level, all those tiny particles, they don't experience time like we do. It's not like they're moving along a timeline. They're just in these states, jumping between energy levels. It's a whole other game down there.
So instead of picturing, I don't know, an electron like a little spaceship flying through time, it's more like it's blinking in and out of existence at these different energy levels. No smooth ride for them.
Yeah, that's a helpful way to think about it. And the source gives us a couple of examples. They're pretty wild to show what this means.
Hit me with them. I'm ready to have my mind blown again.
Okay, first up, the quantum eraser experiment. Basically, physicists managed to change how a particle acted in the past by messing with a measurement they made in the future. If time was just this fixed, straight line, that shouldn't be possible.
Hold up. The future changed the past. That breaks, every rule about cause and effect. This is worse than black holes.
It's a paradox for sure, and it shows us how much we don't get about time, especially once we go down to that quantum level. It's like down there, past, present, future, they're all mixed up in ways we're just starting to figure out.
Okay, deep breaths. What's the other example? Please tell me it's a little less brain-melty.
Well, it's still pretty wild. It's called quantum superposition. Basically, the idea is that a particle can be in multiple states at the same time until someone actually looks at it, observes it.
So till we measure it, it's basically living out multiple timelines, parallel universes at once.
It makes you think, right? Challenges that idea we have that time flows in one direction. At the quantum level, time's way more fluid, way more uncertain.
Okay, I need a minute to process all that.
Yeah.
We went from questioning clocks to black holes, and now quantum mechanics is just, wow. But we've got one last stop on this time-bending tour. The Big Bang. What we usually think of as the beginning of time. But what happens to that idea if time isn't even real?
That's where the source brings in this idea of deep time. So if the Big Bang was all about energy, right, and energy means motion, well, then there must have been motion even before the Big Bang.
So instead of thinking of the Big Bang as the start of time, it's more like just a really big event in this bigger, older idea of deep time. Like the universe didn't just appear, it was already doing something, we just don't get it yet.
Yeah, exactly. It's suggesting that the universe didn't begin in time, it just changed from some other state of energy into the one we see now.
Whoa, that brings up so many questions. Like, what was that earlier state like? What rules were there? Were there other Big Bangs? This feels like we're just scratching the surface.
And that's what's so exciting. This way of looking at time, it opens up so many possibilities. It makes us question everything we thought we knew about the universe and our place in it.
Back for round 3 of the deep dive. Feels like we've traveled to the edge of the universe and back, trying to grasp this idea that time might not be what we think.
It's been a wild ride for sure. Clocks, black holes. We even dipped our toes into quantum mechanics.
My brain's definitely had a workout.
Yeah.
So let's try to bring it all together. This big idea we've been chewing on, what if time isn't this fundamental force controlling everything, but just how we experience energy and motion?
It really flips everything on its head. Could change how we see everything, from our daily lives to the whole cosmos.
I'm still wrapping my head around it. Like, one of the biggest things for me is, how does this change the way we think about the laws of physics? The ones we think are, unbreakable.
Totally. Take entropy, for example. Always hear it increases over time, right? Leads to disorder and decay. But if time isn't the thing pushing it, then entropy's just about energy finding its most stable form.
So it's not that things have to fall apart. It's just energy doing its thing, spreading out, trying to be balanced.
Exactly.
And what about black holes? We think of them as where time stops, But maybe it's more that gravity there is so intense it warps everything, that energy acts in ways we can't even imagine.
Like our human idea of time just can't keep up with what's going on in those spots.
Right. And then quantum mechanics, that just throws everything out the window. Particles being in multiple states at once, even messing with things in the past. Time's way more fluid than we thought.
The quantum world operates on a whole other level. Past, present, future, they're all jumbled up.
And deep time, this idea that there was something before the Big Bang, that's a huge one. Makes you think maybe the universe didn't start with the Big Bang. That was just one point in a much bigger story.
Humbling, right. The Big Bang, what we thought was the ultimate beginning, maybe it was just a transition from something else.
Whoa. Okay, I'm going to need a few more deep dives to really let this all sink in. But it's been amazing. Thanks for taking us on this journey.
The pleasure was mine. And even though time might be an illusion, the way we experience the universe, the awe and the wonder, that's real. So keep questioning, keep exploring. Who knows what else we'll discover out there?